This is a quick review of going from chemical formulas to chemical names of those compounds. You first have to determine if a compound is ionic or covalent. An ionic compound is one that has metals bonded with nonmetals, while covalent is nonmetals only. All the green ones on the periodic table here are metals. The yellowish ones are nonmetals. The blue ones in between are metalloids. They have properties of both metals and nonmetals, though they tend to bond covalently more often, but we won't focus on those too much. So what I've created is this flow chart in order to help you name ionic compounds. Remember, ionic are the ones with a metal and a nonmetal. The first thing you have to ask yourself is how many different elements are there? If there's only 2, that means those are monatomic ions. So you go this way. If there's more than 2, it means you have a polyatomic ion, and you follow this way. Okay, so the first question is how many different elements are there? So if we were to do an example, let's just say we have this, it's a 2. This compound, CaCl2. So the first thing we ask ourselves, how many different elements are there? Well, I have Ca and I have Cl. That means I have 2 monatomic ions, so I go this way. Is the metal a transition metal? So I'm going to look back at my periodic table. The transition metals, remember, are this group here in the middle. So I find calcium, which is right here, or sorry, Ca, which is right here, and it is not a transition metal. So is the metal a transition metal? No, it's not, so I follow this way. So I write the name of the cation, which is the metal, which Ca is calcium. So I write the name of the metal, calcium, and the anion, which is the nonmetal. But remember, the anion will end in IDE. So Cl is chlorine, but to make it end in IDE, we change it to chloride. That's it, calcium chloride. We'll do one more example for ionic compounds. Let's just say we have LiNO. Okay, let's say we have LiNO3. Again, we start at the beginning. How many different elements are there? So I have Li, I have N, and I have O. So there's more than 2, which means we have a polyatomic ion. So you have to use your polyatomic ion chart to find this polyatomic ion. This is the polyatomic ion chart. If you notice, there's only one cation. So most of the polyatomic ions are anions. Anions are always the second part in a compound. So we have Li, and then we're going to have NO3. So I need to look for NO3 on this polyatomic ion chart. So I look. NO3 is right here, and that is nitrate. So I found it on the polyatomic ion chart. Now I need to ask myself, is it a cation or is it the anion? So nitrate has a -1 charge, which makes it an anion. So I come back to my flowchart and I follow anion. It says write the name of the cation, which again, cation is the metal. So the name of this one is lithium, Li. Lithium. If it is a transition metal, include the charge as a Roman numeral followed by the name of the polyatomic ion as it is. So lithium is not a transition metal, so I just include the name of the polyatomic ion as it is, which means I do not change the ending. So the name of this compound is lithium nitrate. Excuse my handwriting. One of the hardest parts is going to be if it's a transition metal. Okay, transition metals, you have to indicate what charge the transition metal has. And to do that, I'm going to just do a quick example. Let's say I have CuCl2. If you remember from my other video, the crisscross rule, we take the charges and cross them down. This time we have the numbers already down, so we're going to take them back up. If there's no number here, that means there is a 1. So we take that back up. So that means Cu is plus 2. Cl is minus 1. The first element is always going to be positive. The second one's always going to be negative. Okay, and then I have to check. Cl, is it actually negative 1? And it is in group 7, so yes, it will be negative 1. Since this one is correct, this one will be correct too. So the charge of copper here is plus 2. So that's naming ionic compounds. A little bit differently is naming simple covalent compounds. Now I say simple because we're only going to have 2 elements. When we start having more than 2 elements, then it gets a little bit more complex. And remember, covalent compounds are known as molecules. They're nonmetals only. So we're going to work with the example H2O. Now I know you know that's water, but we're going to give the actual scientific name for it. So the first question, is there a subscript for the first element? And a subscript is the little number. So H, yes, it has a subscript, so we follow yes. It says write the prefix associated with the subscript followed by the name of the element. Here is a list of the prefixes. So the subscript was 2, which means the prefix is di. So then I write di, followed by the name of the element. H is hydrogen. And then I go here to my next question. Is there a subscript for the second element? I look at O, there's no number there, so I follow no. Write mono followed by the name of the element. Remember, it ends in "ide." So mono, O is oxygen, so it would be oxide. And since mono ends with an O, it just stays like that. So water is also known as dihydrogen monoxide. And that's it for naming these simple covalent compounds. Here's the list of those prefixes if you don't remember them.